Um, so last 2 weeks, we started or we looked at the concept of flowcharts and algorithms and flowcharts. Um, on our last meeting, we had a quiz, and then also we rescheduled the class for um, to still talk about algorithms. Okay, so we have to do the practicals, but I'll reschedule that for our face-to-face meeting at the lab. Our meeting at the lab. Okay. So today we want to go into um, the programming itself, where we are going to focus on the basic elements of programming, specifically C++ programming language. Okay, so we are going to look at what C++ programming language is, what are the basic elements if you take any C++ program, and these elements will cut across all other programming languages. So we are going to look at them. I'm hoping we can at least finish the theoretical part today so that when we meet face to face, we can look at algorithm flowcharts, and then based on those algorithms and flowcharts, we can implement them in C++ by using um, our editor. Okay. All right. I still see people with nicknames. Big Smoke, is that your name or that's your nickname? Please rename yourself. All right. So we want to look at basic elements of programming. So a computer program basically, uh, the gentleman named Big Fish. Stop writing on the screen. Mm. All right. So we are looking at or programming or a computer program basically is a sequence of statements with the objective to solve or accomplish a task. And programming is a process of planning and creating the program. Okay. Now, we talked about algorithm and how algorithms are a set of unambiguous instructions to solve a problem. Okay, and one of the characteristics we mentioned about algorithms is that um, it is independent of a programming language. It is independent of a programming language. That is to say that given any algorithm, you should be able to implement it in any programming language of your choice. Mhm. So if we take an algorithm and in this context, we want to implement it in C++, okay, what do we do? The first thing we need is what we call an IDE. You need an IDE. An IDE simply means an integrated development environment. Integrated development environment. Okay. So this integrated development environment basically is an environment which has resources you can use to develop or implement your algorithm by writing a program. Okay? So it's a software. It's a software that combines common tasks, okay, to help you to develop or help programmers to be able to write their program, test the program, uh, build codes, and so on. Okay, now, these IDEs include some specific features. Okay, one of which you would say um, it has what we call um, the editor. It has an editor built into it. Okay. It also has a compiler. You know what compilers are? They translate our source code in the form of a high language to a low level language, or what we call the machine language. Okay. So it has uh, an editor, it has a compiler, okay, and it also has what we call code completion tools. Code completion, code completion tools. Your IDE um, also has what we call a debugger. The IDE also has what we call a debugger. Okay. So, like I said, IDEs, it can be used for development of your programs, be it mobile programs, your web programs, and everything. So it's not like you you just write a program like in Microsoft Word or anything. Okay, so there are environments in which you write your programs, and these environments have built into it then editor. So the editor works like Microsoft Word, Notepad. Okay, so what they do is they highlight the syntax. It has features like syntax highlighting. Okay, and some of this syntax is what we are going to discuss in today's class. Okay, so it highlights the syntax. So the syntax is based on a particular element of the program. They would always have maybe the same color. Okay, so if it's if it's some of these elements, we say maybe comments, keywords, data types, variable names or identifiers, and so on. These are all elements or components of your program. Okay, so if a word or a statement or um, a character falls within any of these elements, okay, that particular syntax will take a particular color. Okay, so that is what we call the editor, and that is where you write your code. Then the compiler is the software which will translate your code that you've written into um, um, uh, into the machine code. Okay, for your computer, yes, for your program, or for the computer to stand, give you an output. And then also the code completion tools are um, tools that are available to help you run your code, to check for issues within your code, so on. And one of which is what we call the debugger. So it helps you to resolve any form of error in your code. Okay. Examples of IDEs, there are a whole lot. Okay, there are a whole lot. There is code blocks, especially when it comes to C++. Code blocks. Code blocks is used to, it's also an IDE which is used to handle um, applications or write your programs. Okay. Then there's also Visual Studio. Visual Studio. There's Visual Studio. There are other platforms like IntelliJ, Eclipse. Okay, and a whole lot of IDEs. Okay, when it comes to C++, we have another one known as Dev C++, which we'll be using in this course. Dev C++. Okay. So these are all examples of IDEs. Examples of IDEs. Examples of IDs. Okay, and there are a whole lot of them. Okay, so I'm going to open some IDs to you and take you through some of the features that I mentioned. Some of the features. Okay, so that anytime you are using an ID, you take note of these features. Okay, I think I left another one out. I left one feature out that has to do with what we call the terminal. The terminal. The terminal. Okay, so usually the terminal is the interface where when you run your code or execute your code, you see the output, okay, displayed. Okay, so that's the terminal. All right, so let's look at one IDE. This IDE here is called code blocks. Code blocks. Okay, now code blocks is an IDE that can be used to run various programs. Okay, so you can use it mostly for C++ and Fortran, Fortran, and then C programming. Okay, you can use your code blocks to do that. Then we have um, here to dev C++. Okay, so dev C++ is also an integrated development environment which you can use to write your C++ program, okay, and C program. Then I think we mentioned IntelliJ, so I'm trying to load it so that you see how that also looks like. All right, so okay, Visual Studio. So this is Visual Studio, which is also another environment you can use to write your program. Mainly, you can write your Java programs, C++, Visual Basic, C Sharp, Python programs. You can write all on this platform. Then we have IntelliJ. IntelliJ. So IntelliJ is also um, integrated development environment where you can write your programs. For instance, if you want to develop your application, okay, so you can do your Python program. These are all languages and frameworks that you can use to develop the application. So when it comes to Flutter for your mobile application, Java application, Android applications, and so on. Okay. And we'll be using this particular application ID, this environment next semester when we are learning um, or when we are looking at Java programming. Okay. Then let me open a few other ones. So that's IntelliJ. So let me just show you the last one, um, which has to do with MATLAB, which is also a language, which a tool that you use in programming, mostly used by engineers and computer scientists. Okay. So it's called MATLAB, Matrix Laboratory, okay, which is also a tool used mostly by engineers and those in the field of mathematics and computer science. Yeah, I think during your top up, when you do your top up, you are going to use it in one of the courses. If my memory serves me right, I think numerical methods. Okay, so it's also a powerful tool which you can use in writing your program, mostly MATLAB program. All right, so like I was saying, these are all IDEs and they have built into them some features. Okay, so let's start with the code block. So code block has um, an editor. Okay, so if we say an editor, what do we mean? An editor is just the interface where you write your code, the interface where you write your code. So for instance, if I go to new, okay, and I click on new file, this interface will help me write my code. Okay, so maybe let's say let me write some simple Java code. Hash include IOStream. Okay, so it helps you write your code. Now you can write your code here. Okay, this is called the editor. Okay, but this code you've written here would only work if you have a compiler in this particular IDE. Okay, now the compilers are specific. Okay, they are specific. So for instance, if you are writing a C++ program, you need a C++ compiler. You need a C++ compiler. So this C++ compiler should be installed or should be available on this code block IDE in order for you to run your code or your code, yeah, or your code that you've written here in C++. You need a C++ compiler to run it. Okay. So um, it's been a while I used this, but let me try to look for where the compiler is. All right. So it has here plugins. See. Okay. Yeah. So it has the editor then the compiler. So when I click here, it's supposed to show me all the compilers, okay, and the various languages. So every programming language, if it's a compiler-driven programming language, you should install the compiler. If it is an interpreter-driven programming language, you should have it installed. Okay. So, um, so this is one GUNCC compiler. Okay, so this is a compiler that is for C++. Okay. So what you do is you check it to make it available to run your code. Okay. Then it also has built into it what we call the debugger. A debugger is for handling error in your program. And then we have the terminal. So the terminal usually will be down here. Anytime you run your code, you see the output there. Okay. Then we have the um, dev C++, which is the tool we use for this course or the environment we'll be using. Okay. So the dev C++ also has these features that we mentioned. So if you create a new source file, okay, you see the editor. So the editor, you can type in your code. Okay. So this is just a syntax I've just typed here. Okay. And this is typical of an editor. Okay. Now this editor is mainly running on the C++ compiler. So you can see it's here TDN GCC, okay, with different versions. So this one, the compiler is pre-installed. Okay. At the same time, this compiler can run your C program as well. All right. So this is based on or it's based, it has the syntax highlighting. Okay, so you can see that the text I have here on line 1 is green. Okay. The text I have on line 2 is black. Even though it's black, there are some that are bolding and one which is not bold. Okay. Then you can see here also, this word is bold. This is not bold. They are all black though. This is red. This is also red. Okay. This is bolding. This is purple. Okay. So you can see that the various colors or the syntax, the text we are seeing here has different colors. Okay. So these different colors we have here elements or show the
So, Prince, I can't hear what you are saying. Like,
these different elements we have here show the or indicates the various elements, okay, of your program. Okay, they indicate the various elements of your program, and they have been highlighted, okay, or they are called the syntax highlighting. So you can see all the syntax and the color code that have been assigned to them. Now, what happens is that it is able to um, it is able to even guide you when writing your program. So when you get to a point where you make a mistake, okay, you can easily see that maybe you are typing in a keyword, okay, and that keyword usually should come out as bold in your text. Okay, so once you are typing that keyword and you realize that it's not bold, what will happen is that, for instance, I want to type this, it's a keyword, and I start with a capital letter. Okay, automatically you notice that this is not bold. So that should prompt you that you are making a mistake.
Hello, sir. Say hello.
Who is this uncivilized individual? Hmm? How do you unmute yourself in the middle of the child shouting? Can we go on?
Yes, sir.
All right. So, like I was saying, so you can see here that the int, okay, is supposed to be a keyword, but because I've started with a capital I, okay, it's not following the syntax of C++. Okay, so just by looking at the color coding, syntax highlighting feature, you can even see that, or you'd see immediately that it's wrong. Okay, that's if you know these keywords in C++ programming language. Okay, so like I was saying, these are some of the features of an IDE. Okay, if we run this code, we'll see it appear in a terminal form. So a terminal sometimes can come in the form of your command window. Okay, so it can come in the form of your command window, like we can see in this form. Okay, it could also come on your screen, or some are built into the IDE. Okay? Then you can do your debugging and so on. Okay, all right. Emmanuel, your hand is up. You have a question? Hello? Hello?
Let's move on. Say.
All right. Okay, so so that's basically what an IDE is. Okay, and like I said, we'll be using the dev C++ IDE. So now let's go back to the document. Yes, Paul, your hand is up. Do you have a question?
Yes, please. Thank you for the opportunity. Actually, we have number one, number two. I want you. Oh, please display that screen again, please.
Is it the writings?
Yes, please. The
Or
dev C++.
okay.
Number two, using namespace std. Like, what does it mean? What does it do? What is the
So
function of that statement?
relax, my brother.
Okay.
I'm not explaining any code. We are talking about the environment where you write your code. Okay, so we are not, this is just a syntax I've written. Okay, and I'm explaining the features of your IDE, especially with the editor, how it's able to color code your text. Okay, so I'm not explaining the code yet. We'll go into the elements one by one. so know what it's doing.
Okay.
All right.
Please, thank you.
Jacob, you're welcome.
Sir,
Yes, Jacob.
can you use ID like atom or bracket for C++ programming?
I don't know if you can use it. I've not used it before. So unless you search, make that
What
search to
about
see.
Visual Studio Code?
Yes, Visual Studio Code, you can use it. So you need to add your C++ plugin to VS Code.
Okay,
Yeah. But
thank
for
you.
Atom, I don't know, unless maybe check.
Okay.
Yeah. All right. Emmanuel, your hand is up again.
Yes, sir. Hello, sir.
Yes.
Please, I wanted to ask, when does it become bold and when does it become light?
Yeah, so this color coding actually differs from interface to interface or IDE to IDE. Okay. And you can actually change it. For instance, I think that option should be somewhere here. Okay, you can actually change those features, how you want your color to be, the font type, and so on. So you can see from my screen, okay, the type of color I want. Okay, so there are the various elements. If it's a keyword, if it's a symbol, the color you should take. Okay, so it differs from IDE to IDE, okay, and how you want it. It's like you have your phone, your smartphone, and someone prefers using a light mode. Someone prefers using maybe a dark mode. Okay, so those features can change. But what I'm trying to say is that the various syntax we see, the various elements we are seeing here, okay, we are going to go into them one by one, and then we let you know what, if it's bold, what it means. That's for Dev C++. If you are using code blocks or VS Code or any other platform, it's different. You get me?
Yes, sir.
It's different. Okay, so this is, so you should just know the ID you are using and the color code when you see a particular color, what it means within that particular ID. Okay. Yes, Opoku, Prince Opoku. Prince Opoku, do you
Yes,
have a
sir.
question?
Good
Yeah.
evening.
Yes, good evening. Yes, please,
Yes, sir.
Prince, ask your
Please,
question. Yeah.
visual code. Yes, sir. I'm on it, sir.
Okay.
Please, I'm asking that. You see, I can see that you said Dev C++, VS Code, and then what of Notepad?
What of what? Notepad.
Yes, sir.
So do you mean Notepad like this? Like the Notepad we have on in Microsoft Word? Sorry, on Windows.
Yes, sir.
So the IDs are like notepads. Okay, they are like notepads. For instance, there's one software known as Notepad++. Okay, it's just an IDE. It's just, it's just an editor. Okay, so Notepad, like you mentioned, is an editor, just like Microsoft Word. Okay, so the editors are the environment in which you write your program or your code. Okay, now if those environments, like you can see here, doesn't have a compiler built into it or installed in it, you cannot run your program. It is just an interface to write your application. But to be able to run the code that you've written for it to give you your outputs, then you need to add your compiler or interpreter to it. You get me?
Yes, boss.
Okay, all right. So let me take the last question. I see a hand up. Is it Richard? Christopher, do you also have a question?
Yes,
Okay, Richard, let's go.
yeah. I mean, what tool will you use to correct the wrong code you have written?
No, they are mostly, some come with debuggers which will suggest to you where the error is occurring. Okay, so it's also up to you to be able to identify that, know how the debugger works, and be able to use it. Okay, so there are others too. By observation, you just go through the code and you can tell that, okay, this is where the error is.
Okay, thank you.
All right, okay. Okay, so let's look at, go back to our material. Okay, so we want to focus on the elements of programming, okay, of C++ programming. So I'm going to take this code here, copy it and paste it in the dev C++. And we are going to use that to explain the various elements. Okay. So I'll do copying instead of typing it all. All right. So this is the code. It says here that this is a simple C++ program that displays 4 lines of text, including the sum of 2 numbers. Okay, so you have here line 5 hash include IO stream, line 6 using namespace std, line 7 int main. Then you have your curly brackets, you have your int number, you have your line 10 num equals 6, line 11 C out, C out, C out, C out, then return, and then your closing brackets. Okay, so this is a simple program to output 4 lines of text. Okay, outputting 4 lines of text. Okay, now in this particular code has all the elements or basic elements of programming we are going to look at. Now, what is this code supposed to do? It's saying that when you compile and execute or run this program, the following 4 lines will be displayed on your screen. So line 1, my first C++ program. Line 2, you have the sum of 2 and 3 is 5. Line 4, you have 7 plus 8 equals 15. Then line 4, you'd have sum equals 6. Okay. So let's go back. I'll save this work. So save as. Let me save it on desktop. Say example 1, and then I'll save it. Okay. Now, after saving it, there are these 3 buttons here. One is compile. Now, the compile button, what it does is this button will now translate this program we've written here. Okay. This program we've written here from line 1 all the way to line 16. Line 1 all the way to line 16. We call this your source code. Okay, so anytime you hear source code, it means the code that you've written or that has been written in the IDE. That's your source code. Okay. So when you press this compile button, it's going to translate your source code into a machine code. Machine code. So machine code is your binary or your machine language code. Okay, now it's going to do this so that the machine can understand the syntax or the command that you are giving to it. Okay, so it does this, which is what we call compile. Okay, so if you hear the word compilation, simply means that translating your source code or your high-level program, in this context, C++, to a machine code. Okay. Now, once it does that compilation and there's no error, okay, and there's no error, it means that your code, it means that the computer now understands the source code here, this high-level program you've written. Okay. So if you look down here, you can see some compilation or some compile log. First, it said errors 0, warning 0. It shows you the path where the file is saved. It shows you the output size and then shows you the compilation times, which works within some seconds or microseconds. Okay. So what's happening here is it's compiling this program you've done here so that the machine can now understand. Okay. Now, after compilation, the next thing you do is to execute the code. Execute. Or another word we often use is run. Okay. Execute the code or run the code. Now, in running the code or executing the code, there's a button here, okay, which is used to run or execute it. What does it mean to run? To run the code means that, okay, now the computer understands that, understand the syntax or the source code you've given it. Okay, it understands the syntax. So it will now give you the response that you want. For instance, you want to, this is your source code, or this is your editor, and you've written your source code, and you are saying 1 + 1. Okay. Now, this 1 + 1 will go into your, has to be translated into machine language. So let me use MC for machine language, and then use our machine code, and then use the SC for your for the source code. Okay. Then here you have the compiler, or here you compile. when you compile, it's going to give you your source code. Sorry, your machine code. Now, this will not give you two. What it will give you is some combinations of zeros and ones. Zeros and ones to show that, okay, now the computer understands your code. Then this combination of zeros and ones will now be, you now run the code to get what we call your output. Okay. And the output, when you add 1 plus 1, your output will be 2. Your output will be 2. So at this point, you run the code, or what we call execute. Okay. You execute or you run your code. So first you have your source code. The source code is compiled. After compilation, you get it in zeros and ones. If there's no error, then you can now run the code to get your output, which is 2. Are we all here?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So basically, that is how your C++ program will run. Okay. Now, what if you have an error? What if there's an error? So let me just take this program which ran correctly, and then let me change this character here. Let's say I'm omitting this semicolon. Okay. Then I compile the code again. Now you can see down here that there is, let me magnify this so that you can see it clearly. All right, so right here, you can see an error message. Okay, so it gives you the line where the error is occurring. It shows you the colon. Okay, it shows you the file where the file was saved, and then you have here the error message. Okay, you have the error message. So these are things that you need to take note of. Sometimes you go through the error, you are wondering where the error is occurring. Okay, so even in this case, the line has been highlighted. Okay, so for instance, let's look at this. This is to say that, okay, the source code you have written doesn't follow doesn't follow the C++ syntax. And we've learned what syntax are. Okay, we said syntax are rules governing a particular language. Okay, so the same way English language has its syntax or grammar, and you go to French, it also has its syntax, has its grammar. Okay, it has its set of rules that you use. You don't write your essay in English, and then in translating it to French, you want to translate it word by word. Okay, French also has rules it follows. So similarly, your C++ program also has a syntax, it has rules. Okay, so if you don't follow those rules, for instance, the error we introduced in this code, okay, is going to give us a syntax error. So looking at this error, it's telling us that at line, or the first one here, it doesn't show us, but it gives us a message that in function int main. Okay, that's supposed to tell us that, okay, your error is appearing or is occurring inside the main function. Then it shows us the line and then the column where the error is occurring. Okay, then it says that what expected initializer before your num. Okay, then we come to the next line, line 14. It says that error num was not declared in the scope. Okay, so basically what it's trying to tell us is that the no, sorry. All right. So basically what it's telling us is that it expected a value, initializer before this int. Okay, but before this num, but we've done that here already. Okay, just that we didn't put semicolon there. Now the semicolon here is like you are ending the statement. Okay, it's like you writing a statement and putting full stop at the end. Okay, so that is how a C++ syntax works. Okay, so what will happen is that if you have this form of error in your program, if you have this form of error in your program, your code can't be compiled. Okay? The computer will not understand whatever source code you've written. It doesn't understand the source code, so you will not get your outputs. Are we following?
Yes, sir.
Okay, so that is how the IDE works. That is how your programs will be compiled. You run it, and then you get your output. Okay. All right, so let me clean the screen, clear the drawings. And now let's look at what this program here is doing. So what I'll do is I'll compile, no error, and then I'll run it. Okay, so this is the terminal. This is the terminal. So the terminal is showing in the command prompt. Okay, so this is the output of the code. So it's going to print out 4 lines. It said the program is supposed to print out what or display 4 lines of text. Okay. Display 4 lines of text. So if you look at it carefully, the first line, which is, so I've just placed it close to the respective lines where it's supposed to print out. So if you look at the first line, which is this is the code. Okay. So it's printing out my first C++ program, and that's the output we have. So this over here is the output. Okay. Then the next one is, it says the sum of 2 and 3 equals, and then you have here 5. So it's printing out the sum of 2 and 3 equals 5. Then we have the next line, which says 7 plus 8. So 7 plus 8. Then it comes here to perform the computation of 7 plus 8. So it gives us the output 7 plus 8 equals 15. Okay. Then this one says num. Okay, this one says num. So num equals 6. Okay, so we've already said that num here should be equal to 6. So it's referencing the num over here, which is 6. Okay, so we have the output num is equal to 6. Okay, all right, so with this explained, let's go and look at all these features, all these elements one by one. Okay, so that we look at what is happening. After that, I'll take your questions. So those with the hands raised. All right, so it says here that just like we can see, so the 4 lines, the output we just saw, it says these lines are displayed by the execution of the 3 statements. Okay, they are supposed to be 4. So we see the C out for the first one, the second one, the third one, and the fourth one. Okay. Now it says here that the statement, which is the first one, my C++ program, it said this is an example of C++ output. It forces the computer to evaluate the expression after the pair of, so the 2 less than symbol. Okay. After the pair of these 2 symbols. And then it displays the output on the screen displays the output of this on the screen. Okay. Then the next line also uses or contain various types of expressions, such as the arithmetic expression and strings. Okay, so the next line so this is a string. Okay, we will look at what they are shortly. Then this is an arithmetic, and sorry, this is also a string. Okay, now this one is also a string because they are in the double quotes. But this particular statement here is an expression. It's a mathematical expression. So this 7 plus 8 equals, it's not the same as this. This is a mathematical expression, 7 plus 8. However, this is a string. Okay, so string are basically combination of characters. Okay. Then we have, so it's saying that the next one, the 7 plus 8 is an arithmetic expression. However, the 7 plus 8 with the double quotes on it they are strings. Okay. So strings, what they do is that they evaluate, a string evaluates to itself. Okay, so a string will evaluate to itself. So what it means is that it will print out itself the same way it was written. That's how come with the output, we had 7 plus 8 equals. Okay, but when it comes to the arithmetic expression, what it's doing here is that it's going to add the 7 to your 8, which will give us the 15. Okay, which will give us 15. So you can see here the string expression was printed just like it was written. And then the 7 plus 8, which is an arithmetic expression, gave us what? 15. Okay. All right, so then let's come to the beginning part. So the beginning part of the program, okay, we have here what we call comments. Then we have our hash include. So what is this hash include? What is it? What does it talk about? Okay, or why do we have it in the code? So the hash include IO stream allows us to use what we call the predefined object, okay, which is C out to generate output, and the manipulator end L. Okay. Now, in C++ programming, we have what we call C in and then C out. C in and then C out. Now, C in is used anytime you want to perform input. Okay. And C out is used when you want to do your output. And our last meeting, I told you like words that you should take note of in algorithms that are synonyms to input and output. Okay, so for instance, when you are doing your input, you see words like scan. Okay, anytime you see scan, it means input. You see word like what's this other word? You see word like scan. You see word like read.
Run.
Okay, so a word like read. Okay, these are words that are synonym to input. Okay, so anytime you are reading an algorithm and you see a word like this, okay, it should just tell you that they want you to, or the task is asking for an input. Okay. Then when it comes to output, you see words like display, okay, like we use in the algorithm. You see words like print. Okay. You see words like write. Write. In some programming language, they use the word echo. Okay. So these words are synonymous in nature. So when you see them, you can always interchange them. Mainly when writing your algorithm. Okay, so if you want to say input, you can say scan or read something. Okay, so in C++, it uses C in. So like the in here and then C out. In a program like C programming, it uses the word scanf for input. Scanf for input. Then if it wants to print, it uses print out. Okay. If you come to a programming language like Python, it uses input to accept input, and then it uses the word print for output. If you come to, say, Java, okay, Java uses scanner with system.in for inputs. And then when it wants to print, it uses print with system.out for output. Okay, a programming language like VB. VB uses read anytime it wants to perform input. Okay, and when it wants to perform output, it uses write or write line, print, read or read line. Okay, so these are words that you'd see synonymous in most programming languages as you go on regarding input and output. Okay, now this input and output falls under a term known as IO stream. IO stream. Okay. Input and output stream. IO. Input output stream. Okay. So that is what we are using here. Okay. Now, when we learned about algorithm, we said that one of the key characteristics we saw has to do with inputs and outputs. Okay, so for basically every program, there might be some form of input. Okay, and there's an output. Okay, so one of the key, we call this a library. Okay, library. Now, one of the key library, into brackets, header files, one of the key libraries we have that you need to introduce in every program, especially your Java program, sorry, your C++ program, is what we call the IO stream. Now, this IO stream is going to handle the inputs and the outputs in your C++ program. Okay, and it's one of the libraries that you would use every time you write a program. Because your program basically will be doing outputs, inputs and outputs. Okay, just like we saw from last week when we were discussing the sequence algorithms. Okay, so you want to find the area of a circle, or you want to find square roots. Sorry, you want to find a simple interest. These are all things that will require inputs and outputs. Okay, so in every C++ program, this system.out, sorry, IO stream is key. Okay, it's a key library that you have to include. Okay, what is a library? Basically, a library is a syntax in your program, okay, which is made up of collection of functions. Okay, has a lot of functions. So, for instance, one of the features that makes Python one of the popular programming language now is because it has a lot of libraries. Okay, now just picture library as the physical library we have in our schools. Okay, when you go to the library, you can go to you have a shelf, or there are shelves there. Then the shelves, for instance, have different names. So maybe if you go to your library and you want a book on mathematics, you see over there written maths. So you see the collection of books that are under mathematics, different subjects. If you want a book on computer science, you go to the library, you see a collection of books on the computer science shelf. If you move to, let's say, um, which other course, maybe anatomy, okay, you see books that are under the anatomy shelves. Okay, so that's the same way libraries are. So in the IO stream library, you'd have functions. We call them functions. So the functions are like in the scenario I just gave, the functions are like the books. Okay, so you see a function that falls under, or you see functions that falls under the IO stream libraries. And these are functions that will help you perform inputs and outputs. Okay, so there are a whole lot of functions in C++. And so my assignment for you is go and look for 10 C++ functions and 10 libraries under each function. Sorry, and 10 C++ libraries, 10 libraries in C++. And then for each library, so if you take the first library, let's say CMaths. CMaths is a library. So under the CMaths library, look for 10 functions. 10 functions. Functions under CMAT library. Okay, so I can give you a couple of them. So there's a function known as the ABS, ABS absolute value. Okay, this is a function. Another function can be the square root function, SQRT function. Okay, so these are related to mathematics. Okay, now let me just give you a fair idea. If you've done Excel before, okay, I believe these are things that you'd see a lot in Excel. So for instance, we have here our Excel. Okay, if you go through Excel, you see it has, I think, formulas here. So under the formulas tab, you see the function libraries. Function libraries. Okay, so there's a financial library, there's logical, there's text, there's time, there's a whole lot of them, a whole lot of function, statistical function, statistical library, engineering library, and so on. Okay. So if we take, for instance, statistical library, these are all functions within the library. So average, uh, uh, distribution, okay, binomial distribution, chi-square, and so on. Count, okay, finding standard deviation, and so on. If we come to engineering, there are libraries like binary to decimal, binary to hexadecimal, and so on. These are all engineering related functions. Okay, so maybe when we come to maths and trig, you see this here, ABS, absolute value, okay, of a number, base, log, okay, pi, a whole lot of them, tan, theta, square roots, a whole lot of them. So the same way Excel, Microsoft Excel has libraries and functions. Okay, in programming also, there are libraries, and for every library, it has a collection of functions. Okay, so your question is to go and look out for 10 C++ library, and for each library, state 10 functions each. Okay, you can even go further to tell us what the function means. Okay, all right, so that's your assignment. Like I always say, it's your try assignment. Okay. I might bring it up in a quiz. All right. So that's it for the hash include. Okay. So let me take some questions before we look at the next statement, which is using namespace. All right, Vincent.
Okay.
Vincent.
So, good evening. Hello.
Hello, yeah.
Yes, sir. Sir, please, good evening.
Good evening.
So please, the first is, can you term it as pre-written code?
Can you term what?
The functions are pre-written code.
Yes, so the functions they are of two kinds, okay? Like I mentioned in our first lecture, the various topics we are going to look at this semester. One of them is functions. Okay, so the functions are of two types. There is the predefined, or what we also known as built-in functions. Okay, so they are what you just mentioned, the pre-written ones. They already exist for you to use. Now, before you can use them, you need to identify the library in which that function belongs to. Then you can use them. Okay. Then there's the user-defined one. So the user-defined one is where you, the programmer, will maybe take a formula and present it in the form of a function so that it can be reused in your in your program, okay, or in other programs. Okay. So like I said, that is one thing that makes Python one of the popular programming languages because it has a lot of libraries with functions that can do so many things. You can use it for web development, for AI, for software development, and so many other things. Okay, which most of the other programming languages are limited. Okay, even though you can use them for these other features, but most of them are more of your scientific programming languages. Okay, so they are performing just specific, or they work within a specific domain. Okay. Yeah. Paul. So 3 hands are raised. I'll take your question and then we move on. So Paul.
Yes, sir. Please,
Yeah.
thank you for the opportunity. Please, the
Yeah.
question is, you see, when you were teaching us, you opened the Dev C++ window and you were lecturing us on that.
Yes.
It always ended with a word endl, ENDL. That is it the same as, you see, last week during our lectures face to face with the algorithms, we always start with step one, start, then end with the last step, which is stop.
Okay.
Does that
Okay.
stop relate to the end L?
Okay. That's a good question. A good observation there. Okay. So this NDL basically is different from what we have in our algorithms and flowcharts. Okay, but before I explain that, let me just use this opportunity to explain the start and the end we see in our algorithms and flowcharts. Okay, so basically, in C++, okay, the start and the end is represented by this bracket here. So this close bracket, open curly bracket, and the closing one here indicates the start and the end or stop. Okay. Then your algorithm will now be implemented inside this curly bracket. So this is basically like you implementing your algorithm, the code we have in here. This is where your algorithm will be implemented. Okay, so primarily, or what we would see is that we would say that this is step one. The start is step one, right? Are we all here?
Yes, please.
Okay, then this will become, the int num will become step two. Then step three. Okay, then step four. So basically, this is you trying to implement your algorithm. Okay, so the hash include the using namespace, the int main. The int main, we call it the main function. We'll talk about it soon. It's called the main function. Okay. So these parts basically are predefined processes. They are called pre-processing or the preprocessor. Okay, so what they do is that they are initialized, or they are packages that are introduced before you even write the algorithm so that the syntax can flow with it. Okay, in other languages, you import them. In C++, the word here is include. You include it and then you use it. Okay, you use those features. Okay, but in implementing the algorithm, it all happens in here, inside the curly brackets. Okay, all right. So the end L, back to your question, the end L here simply means that after printing the statement, it should move to the next line. Okay, it should move to the next line. Now, if you don't put that end L there, this is what will happen. The output, sorry, let me clear the screen. So without the end line, what will happen is that the output of the first line, after ending here with a full stop, the next line will continue over here. Okay, so let me just remove this from here and let's run it again so that you see what I'm trying to say. So realize that after the first statement is printed, I've removed the end line. Okay, so the next statement is supposed to be the sum of 2 and 3. But without the end line, this sum of 2 and 3 will appear on the same line as my first C++ program. All right. So like you can see, without the end line, it's printing these two statements on the same line. Okay. So what the end line does is anytime you introduce it, at the end of it works within your, it works with your output. It's part of the IO stream, okay, features. So anytime you use your output or sometimes your input, you add it there as a manipulator to manipulate the text, okay, by moving it to the next line. Or after printing it, the cursor should move to the next line to print the next statement. Okay. Jacob, Biafe, and then the last question from Peter. Then
Okay,
we'll
sir.
go on. Okay. Yes.
Based on the compiling and running of code,
Okay.
all the IDEs works on hardware. Can it
Okay.
run? Can we compile and run code on any hardware, or we have specification?
Yeah. So depending on the ID you are using, for instance, you can run them on any platform. Okay. So if you say hardware, um, what do you mean? I want to say something, but I want to get your question
I,
before
I
I
mean,
give the
maybe we
response.
have like 5 million lines of code, and we are compiling and wants to run and see the outcome. Can it run on, let's say, third gen i3
Okay. All right.
machine?
I get your question now. Okay. So we have a course which you learn in level 200, known as data structures and algorithm. I think I mentioned it in our last meeting. That's in this course you learn about computation, the size of the file, how much space it take, how long it will take for the program to even run. Okay. Now, that analysis, based on those analysis, okay, you can tell that sometimes it's not necessarily about the lines of code you've written. And I proved that to you last week when we're looking at the first example, number one, number two. Someone wrote the algorithm with just one line, those two statements with one line. Someone decided to do it in 3 lines. Okay, so it doesn't necessarily depend on the number of lines. Doesn't necessarily depend on the number of lines. Okay, rather the complexity of the code you are writing. Now, when it comes to the hardware, for instance, this code over here is a much simple code. Okay, so preferably any hardware, any computer that we have now should be able to run this code. Okay, but when it becomes complex, and you can determine this complexity based on how you analyze the algorithm, okay, then that will need a higher memory and processor, sometimes not the CPU, but you need GPU, graphic processing units. Example, NVIDIA and Radiant graphics and so on, to be able to run those applications. Okay, but if it's as simple as this, you can run it on any PC. But preferably for a computer science student, since this is not the level which you are going to remain at, okay, you go higher. Preferably a laptop with at least an 8 gig RAM and an i5, okay, should do, because going forward you'll be introduced to softwares and applications that will take a lot of memory and a lot of resources to be able to run. Okay, so you can look at it from that angle. I hope I've answered your question.
Yes, thank you, sir.
Okay, you're welcome. Peter.
So please, when you were explaining the strings, you made a suggestion that strings always print a store. So let's assume writing with C++ goes like starting from, let's say, line 11. You see, my first C++ program is in string form. You've already like double quoted. So what of if you not bring that double quoted or there's no strings out there?
Yes.
What will be the outcome for the print out?
Okay, so that question goes back to the syntax for C++. Okay, so if you don't put it there, then it doesn't follow the C++ syntax. So it will give you an error. So we have this here, and you want to print it. You want the question is that you want to output 4 lines of code, and you want this word to appear. Okay, however, the cout, your output string here or function here, if it's going to print out this statement, then this statement should be handled as a string for it to be printed out. So if I compile this, it's going to give us an error. And you can see that it's highlighted it. And it's telling us what was not declared in the scope. In fact, it's the whole statement here. So it's supposed, the rule is that if you want to have this statement printed or displayed or outputted, it should come in the form of a string, thereby introducing your double quotes. Okay. Are you answered, Peter? Is it Peter?
Yes, sir. Yes, sir.
All right. Okay. Yeah.
Thank you, sir.
You're welcome. I don't know whether to take more questions or to go on. We have some 15 minutes more. So I see a hand up in the chat. Christopher, do you have a
Please,
question?
let's go on.
Yeah, sir, I have a question, please.
Yes, Christopher, ask and then let's move on.
Please, I want to know how do I print output to the console using count?
Well, how do
I print output to the console using count?
That is what we've done here. It's not count, it's see out.
Okay,
See
yes.
out. It's an output string. So that is the example you are seeing here. Okay. But we'll go further into it. This is just to introduce you to the basics.
Okay.
All right. Okay, there's a question in the chat. Let me just read it quickly and then we can continue. So it says, you see on line 12, after the string, a 5 isn't an expression. It is not in a string 2. Why did it print exactly 5? Yeah. So this 5 here is not a string, and it's not a string, okay, but it's an expression. Okay. Now, even though it's an expression, just like we have 7 plus 8, okay, even though it's an expression, it's printing out itself. It's a number, a numeric value. It's going to print out itself. Okay. However, this is an expression in the sense it's not printing out 7 plus 8. Rather, it's printing out the evaluation of this function. Of this expression. Okay. So if we had put here 5 minus 2, okay, what will happen is that it will subtract 2 from 5 and give you 3 as the output. But because we put here just 5, that's how come we are having the output as 5. Okay. All right. Okay, so let's continue the material. Then we have using namespace. So using namespace is allows you to use the cout and the end line without prefixing it with std. STD here means standard. Okay, std : Now, what it means is that if we take out this using namespace, and I'm going to take it out by doing what we call comment. Okay. By commenting it, sorry. By commenting it, what will happen is that anytime I want to use cout and this end line, I need to prefix it with std : So imagine I'm using hundreds of couts and maybe cin and then the end l. These are all related to the IO string. Okay. Imagine I'm using them and I have to prefix every cout in the code with std. Okay, that's going to be a lot of time wasted there. So the namespace std helps to handle the use of the std : in all your couts and end l. So for instance, if I compile the code, you see that it's giving me an error. It says cout was not declared in the scope. Then another one is saying that we should use what std is giving an alternative that use std : cout. If you come here, it said end l was not declared in the scope, gives an alternative std end l. Okay, so if you have a lot of couts in your code and you don't use the namespace, that means you have to use the std : throughout in your code. Okay. All right. Then the main. So main, int main. Okay. Now the int main, this is the heading of the main function. Like I said, it is the main function. Okay. Now the main function basically is where you are more like implementing your program. Okay. Now, without the main function, your program cannot run. Without the main function, the code that you've written cannot run. Okay, you can't run it. Okay. So the main function, that is its role, its place. It comes with this double brackets. Sorry, the open and close brackets. Okay. So the open and close bracket comes. Usually it takes what we call arguments. When we learn about functions, we'll talk more about them, or we'll spend more time on the main function. Okay. It takes what we call arguments, but in this case, there are no arguments. Okay. Then anytime you write the main function, right after it, you add your curly brackets, open curly brackets, and then closing curly brackets. So like I said, the open curly brackets signifies your start of your algorithm, and then the closing one signifies the end of your algorithm. So if you omit one, you'd have an error. You are trying to tell the program that your function hasn't ended, or the algorithm, that's not the end of your algorithm. So it will give you an error. All right. The person asking the question on the HTML in the chat. Okay, like I said, every language has its syntax. Okay, so in HTML, the greater than and less than sign, they are usually used they are used in a different, or they are used in HTML has a different rule as to the when it comes to C++. Okay. The question you are asking is like, we are learning English here. You are coming to say you don't see French terminologies here. So can I explain? Okay. So this is a different language and it has its own syntax. The syntax basically are the rules, the symbols, the keywords. All right, so let's look at another component, okay? So like I was saying, programming languages are made up of set of rules, which tells you the syntax rules, okay, governing the language, and the semantics, which has to do with the meaning of the instruction. Okay, so basically, programming language is a set of rules and symbols and special words. Okay. So now let's look at the elements. So the first element here is what we call comments. Comments. Now, comments are very key in your program. Okay, a typical example is this line 1 to line 4. Line 1 to line 4 is what we call a comment. Okay. Now, the comment, it says here that is parts of good programming is the inclusion of comments in your program. Okay, typically what they do is that your program it helps people to understand what the program is. Okay, to understand what the program is. So, for instance, if I had not written here, if I had taken this line off and then start by the program, anyone who first sees it and doesn't know programming will be wondering what is happening here. Okay, but once I have this here as a comment. Anyone who sees this, what's the name? Is it Define or stop writing on the screen? So anyone who sees it, if you can erase it, anyone who sees this immediately is able to tell what this program is about, even if the person doesn't know how to program. You can tell that, okay, the program here is displaying 4 lines of text, including the sum of 2 numbers. Okay, so comments, even though they are not compiled, now I'm using the word again, comments are not compiled. Okay, they are just there to help you read, understand what the program is about, and even who wrote the program. So you can even put your name in the code as a comment. Okay, so the comments are for the reader, not for the compiler. So you, the person reading the code, the comment is meant for you. There are times where you can write a code for many years, you come back to your code and you don't even remember what maybe a particular line or a block of code, okay, is doing. Okay, but if you always put a comment there, what happens is that anytime you revisit that code, you know that, okay, this is what the code, this part of the code was supposed to do. Okay. So it says that when a compiler compiles your programs to check for syntax error, it completely ignores the comment. Okay. So the comment, even if there's an error there, if maybe I'm supposed to say display and I say it's display, the compiler will skip it. It will ignore it totally because it doesn't compile what we call comments. Okay. So how do we write comments? There are 2 main types of comments in C++ programming. We have the single comments, single line comments, and multiple line comments. The single line comments begin with a double /. Okay, we bring double / like we can see in this case. So these are 4 single line comments. Then we have the multiple line comment. So the multiple line comment, what you do is, so an example is here, you start with your / with your asterisk, you write out your comment, so you can have multiple lines of statements here, maybe about 10, 20 lines. Because it's multiple, if you want to do the single line comment, that means you are doing the double / for all the 20 lines, which is not advisable. So just go to the first line, do your / and star, and then go to your last line, do your star, and then /. Then it's going to comment the entire statement. Okay. So for instance, like this, if I want to do a commenting, I'll just come to the beginning. Maybe I want to comment the entire code. I just come to the beginning. Sorry. The beginning of the statement, my / and then the star. Okay, so you can see it's commented everything. But maybe I want to comment up to where the curly bracket is. So I'll just come to the end of it and then just put the star and then / So you can see that this whole part has been commented out and this part is not commented. Okay. All right. So I think there's still more we need to cover when it comes to the elements. Okay. We have the special symbols. So we see the plus, minus, question mark, semicolon. So if you come to your Dev C++, the special symbols are the ones you see in red. Okay, so we call them special symbols. Then we have the reserved words. Okay, so these are tokens. Okay. If you do a course known as compiler design, you hear more about tokens. So tokens are special words, reserved words or keywords. Okay. So we have the example, int, float, double, constant, using, and so on. So if you look in the Dev C++, these are words that are bold. So this is a keyword or reserved word. Namespace is a keyword, reserved word. So words that are bolding, as you can see here, are all examples of as in black and bold. Let me put it that way. So this one is bold, but it's not black. Okay. So black and bold, as you can see here, are all keywords. Okay. Now, like I said earlier, talking about editors, this will differ. These keywords, the way they are bold here, maybe when I go to a different IDE, like maybe VS Code or code blocks, I'll not see them as bold. Okay, so VS Code or code block would have a different feature, maybe a different color altogether to represent keywords, okay, which might not be the same as Dev C++. Okay, so that doesn't mean if you are writing your code in code blocks and you write your keyword and you don't see it bold, doesn't mean it's not a keyword. What it means is that you are writing on a different environment with a different editor, which has its own features. Okay. All right. So I'll end here for today. We'll look at identifiers, and then we'll talk about data types. Then we can now start writing our program. Okay, so hopefully next week we'll spend time in the lab to be able to write algorithms. I think we are left with drawing the flowcharts. So we use the draw.io to draw the flowcharts. We take an algorithm, then we'll implement it in the lab with C++, using the Dev C++ to implement the algorithm in the C++ language. Okay. Any question?
Yes.
That's all right.